Yeah. Hi. So today we'll discuss problem similar to assignment number 7. Uh, Before that, do you guys have any doubts in the previous assignments? Okay. So we'll get started. Yeah. So the first question is 2 to the power 5 minus 1 design has how many experiments? So for this question, all we need to do is calculate the exponent of 2. 2 to the power 5 minus 1 turns out to be 2 to the power 4, which is 16. So it will have a total of 16 experiments. Is that clear?
Yes.
Yes, sir.
Yes, sir.
Yeah. So the second question is 2 to the power 5 minus 1 design is a half factorial of dash experiments. So again, we know that in total 2 to the power 5 minus 1 is 16 sets of experiments. Because it says half factorial, what we'll do is we'll multiply 16 into 2 and we'll get the answer 32. So the full factorial design should have a set of 32 experiments, out of which in the fractional factorial 2 to the power 5 minus 1, we are just doing 16 experiments. Is that clear?
Sir, can
Yes.
you repeat once?
The answer is 32 or 16.
The answer is 32.
Okay. So that means
Yeah,
full value should be our answer.
yeah.
Or whatever the factors, whatever return, I think 2 raised to 5 minus 2. Even in that case, if written that 1 divided by 4 factorial, 32 is the answer. Am I right?
Sorry, could you repeat that? Yeah.
Equation would be 2 raised to 5 minus 2 design is 1 divided by 4 factorial of space experiment. Then 32 is the answer in same
Yeah,
case.
yeah.
Okay, thank you.
Yeah. So here what we are doing is 2 to the power 5 minus 1 is a fractional factorial design. So in this case, the total number of experiments that we have, we calculated in the previous question is 16. Now the second question asks, this design is a half factorial of dash experiments. So we need to calculate how many experiments are there in the full factorial design. So for that, we'll multiply it by 2 because it says half factorial. So 16 into 2 turns out to be 32. Is that
Thank
clear?
you. Yeah.
So the third question is 2 to the power 5 minus 1 design has the resolution of dash. So for 2 to the power 5 minus 1 design, we'll first make the table for like four uh, different uh, factors, which is 2 to the power 5 minus 1 is 2 to the power 4. So we'll have factors A, B, C, D. So we'll again have the interaction terms like taking two at a time, that is A, B, B, C, C, D, A, C, A, D, and so on. Then we'll have interactions of three of those factors, which will be A, B, C, B, C, D, A, C, D, A, B, D, and so on. And finally, we'll have an interaction of all the factors A, B, C, D. After that, what we'll do is we'll replace A, B, C, D by E. So that is our two fractional factorial design. And since we are replacing ABCD by E, the generator function will be EABCD, which will be EABCD from this equation. And since we have 5 terms in the generator, the resolution here will be 5. Is that clear?
Yeah. Arpit bhai, for minus one, I have a clarity, but sometime minus two, minus three are creating a doubt in my mind because we cannot easily get the answer like current situation.
So, for example, now if we had the question 2 to the power 5 minus 2. So, again, we'll have all these terms. Oh, sorry. 2 to the power 5 minus 2 will be 2 to the power 3, which will be 8. So we'll have in the fractional design, we'll have three factors, which is A, B, C. And we'll have the interaction terms A, B, B, C, A, C. Then we'll have a final term with all the factors, which is A, B, C. And since here the second part of the exponent is 2, we need to replace 2 of these columns with new factors. So first of all, what we'll do is we'll replace this, the most interacting factor, with D, and another one with E. So now our generator will be D is equal to ABC, right? Because we are replacing D by ABC. The other thing will be E is equal to AC, because we are replacing E by AC. Sorry, AC by E. So in this case, like after doing these replacements, what happens is the shortest equation that we have for the generator function is this, E is equal to AC. So this is the shortest equation. Since this shortest equation has 3 terms, which are E, A, and C, so this design will have a resolution of 3. Is that okay?
Okay, thank you.
Yeah. So
Can
first,
we
what?
use resolution table to understand this?
Sorry.
Can we use resolution table?
Resolution table as in?
Resolution table for design of experiments where number of factors are there and number of runs are there and color coding is there. So we can immediately find out what is the resolution.
Just a second. Yeah, you can use a resolution table, but I don't think you will have one in the exam, right?
But if we can memorize, it will be easy.
Yeah, that's just
Yeah.
memorization, right?
Mhm.
Like if
Sir,
you can
so,
memorize, then of course you can just answer it directly. But in case you don't remember, then you can use this.
sir, so
Otherwise,
in
it is
the
for a new comer, it is really difficult to understand this resolution or combination of experiments.
Yeah, but you need to understand how this value comes. No, if you just memorize it, then like if the question comes with something that you have not memorized, then what will you do? Like,
so sir, in the
yeah,
previous one, the E is equal to A, B, C, D. That is the shorter one. No? Then the resolution should be 4, no?
yeah, that is the shorter one. So the generator equation here will be E, A, B, C, D, all of these. Therefore, the resolution is 5 because it has 5 terms. In the second case, this is the shortest equation and it has 3 terms, E, A, and C. So we look at both sides of the equal to. Is that clear?
So if we have 4 factors, then our resolution will be 5.
Yeah, if you have an equation like this, E is equal to A, B, C, D, then your resolution will be 5. If you have an equation like E is equal to AC, then in total you have 3 terms, E, A, and C. Therefore, the resolution here is 3. In the first case, we have 5 terms, E, A, B, C, D. Therefore, the resolution here is 5.
Okay.
Yeah. So it's like taking all these terms, irrespective of whether they're on the left side or the right side of the equal to. So I'll tell it again. So for this case, 2 to the power 5 minus 1 fractional factorial, we'll have a 2 to the power 4 design initially. So which is like we'll have 4 independent factors. Then we'll take all the interaction terms 2 by 2, 3 by 3, and then 4 by 4. Then since we have an exponent of 1 here, what we'll do is we'll replace the highest value term, like not the highest value term, the highest order term with the new factor. So ABCD will be replaced by E. So here the replacement equation is E is equal to ABCD. Then our generator equation will be EABCD. It's just the same thing without the equal to. And since this has 5 terms, E, A, B, C, D, therefore the resolution here is 5. Similarly, in the second case, since the base design is 2 to the power 3, 8, so we have 3 factors, A, B, C. We take all the interactions. Then we replace, since here in the exponent we have 2, we replace 2 of the terms with new factors. So A, B, C and AC we replace with D and E. Here our equations become D is equal to ABC and E is equal to AC. Of these two, the smaller equation is E is equal to AC. Therefore, we'll take this smaller equation when calculating the resolution. So here we have 3 terms, E, A, and C. Therefore, the resolution here is 3. Is that clear? Hello?
Yeah.
Yeah. So the next set of questions has this table given. 2 to the power 3 design experiments are carried out to maximize the biomass production as shown below. So we have 3 factors, temperature, pH, and dissolved oxygen, and we have the result that is the biomass. Based on the data provided in the table, what is the effect of temperature on biomass? So first, what we need to see is where all the temperature. So since all of these temperature, pH, and dissolved oxygen has 2 values, -1 and +1. So we'll categorize them together. So for temperature, all -1 values will be treated as same. And for +1 values, all of them will be taken together. So at the least concentration of temperature, that is at -1, the biomass, average biomass is calculated as 8 plus 6 plus 10 plus 15 divided by 4. So we get a value of 9.75. Similarly, for the maximum concentration of temperature, we get 9 plus 13 plus 8 plus 7 divided by 4, which is 9.25. Then to calculate the effect of temperature on biomass, what we do is we subtract the least concentration value of biomass from temperature from the maximum concentration of biomass, maximum concentration of temperature, biomass value at maximum concentration of temperature. So it's 9.25 minus 9.75, which is minus 0.5. Is that clear?
Yes.
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 Yeah. So similarly, based on the data provided, what is the effect of pH on biomass? So again, we take all the negatives and the positives separately. We'll sum all the negatives for the least concentration value. We'll average the biomass values for the least concentration of pH and average the biomass values for the maximum concentration of pH. Then to find out the effect of pH on biomass, we subtract the maximum concentration from the least concentration average. So which is 10 minus 9, which is 1 in this case. Is that clear?
Yes, sir.
So we have to consider values.
Sorry?
So,
Yeah, could you repeat?
no, we have to consider absolute values. Now, if I
Yeah, we have.
pH on biomass, if I multiply by 8 by minus, it will be minus 8.
No, if there is a negative value, we'll take a negative value. We won't consider absolute values. While adding
But
this
total
up.
yours positive, no? The biomass at least concentration of pH -1 values, you have shown it positives. 8 plus 6 plus 9 plus 13.
Yeah, for the least concentration, we are like taking all these values. So where all minus occurs in pH, these two places. So 8, 6, then these two, 9 and 13. We'll take all those values, add and divide by 4 to get the average. Oh, you're asking in this
That's
case,
my
should we
asking.
have
We have to
minus
consider.
8, minus 6? Sorry?
I think he is confused with the pH column. Actually, he's talking about DO column, but we are on pH column. Problem is on pH column. He is considering, I think, DO column for my 8. For -1 for 8, it's in DO column, not in pH column. pH is positive na for 8 value. Second last row.
Yeah. Is that what you were saying?
No, sir, if you have to correlate effect of pH on biomass,
Yeah.
then we have to take multiplication of 8 multiplied by 0.1, na? -1?
No, no, no.
No.
No, that we are doing. We are in the end, we are subtracting. No. So it's basically the same thing.
Here positive did calculation separately and negative separately, and positive minus negative did in the last row, effect of the pH. So answer will be same, what I understand.
Yeah. So what you are saying
Same.
is we'll take -8, -6, -9, -13. Then we take the average, which will be -9. Then we'll add both of them. That will again turn out to be 1.
Yes, sir. Yes, sir.
Is that what you were asking?
Still, I am confused, sir.
Okay, so since we are calculating what is the effect of pH on biomass, so what we are doing
Yeah.
is for pH, wherever the pH value is negative, we are separating those terms out. So like 8, 6, 9, 13, we are separating out. And wherever pH value is positive, 10, 15, 8, 7, we are separating that out. We are finding out the averages of these two groups separately. So for the first like least concentration, the average will be 9. For the maximum concentration, the average will be 10. Then what we are doing is subtracting the value for least concentration from the value for maximum concentration. So this -1 +1 does not necessarily correlate to pH values. So the pH values here can be 3 and 4 or 5 and 7 or something like that. So -1 and +1 are just like two different values for pH. One is less and one is more. We are just denoting it by -1 and +1. We don't need to multiply it by the pH to do anything. Is
These
that
are,
clear?
sir, primary effect only.
Sorry?
So this is not secondary. No, we are studying primary effect or secondary effect. Means in the video
Primary
it was
effect.
discussed that you have to primary
It's
effect.
primary effect, no? Yeah.
Okay,
So the
okay.
in the
Then
question we are given temperature, pH, and dissolved oxygen. All three of them are primary. So we don't need to multiply anything.
okay, okay.
Yeah. The third here also it's primary. What is the effect of dissolved oxygen on biomass? So again, like we'll separate out all the places where DO is negative and all the places where it's positive. We'll again take the average for both cases and subtract it. So the answer here comes out to be 1.5. Is that clear?
And is it necessary to round up the figures, sir? Now 1.5, can it consider as a 2?
No, no, no. You don't need to round them off.
During the assessment of the assignment, they are not, means they have considered this rounding, sir.
Have them mentioned that you need to round? I
In
don't think
earlier
so.
answer, I think in one case the total
Yeah,
was
I
130.
think that was the only case. Apart from that, like if they
Okay.
don't ask you to round up values, then you don't need to round them off. If they don't explicitly tell you to round off to the nearest integer or something, you don't need to round it off. So is this clear?
Sir, can we have the question number 1 again?
We'll have it after everything. Is that okay?
Sir, no issues.
Yeah. So here we are looking at the secondary factors, so interaction terms. So based on the data provided, what is the effect of temperature into pH on biomass? So here what we are doing is we are multiplying the values for temperature and pH. So -1 into -1 will be +1. Similarly, -1 into +1 will be -1. +1 into -1 will be -1, and +1 into +1 will be +1. So we are creating a new column called temperature into pH. Basically, we are just multiplying these two values to get +1 and -1. Then again, what we'll do is we'll separate all the positive terms for this third column and the negative terms. And then we'll again calculate the averages separately for the -1 and +1. And we'll subtract the average for +1, -1 from the average for +1. So here, the effect of temperature into pH on biomass will be -4.5. So this is a secondary effect kind of interaction term. Is this clear?
So this significance of negative value, it biomass is reduced.
Sorry?
No, this answer, the negative, does it mean that the biomass is reduced?
Kind of, yes. Temperature and pH into time. So the interaction between temperature and pH reduces biomass is what we'll get from this.
Okay, thank you.
So the next question is again like, what is the effect of temperature into dissolved oxygen on biomass? So again, we have the column for temperature, we have the column for dissolved oxygen. We'll make a new column for temperature into dissolved oxygen, and then we'll separate out the positive and negative values based on the third column. We'll take the average for the negative values, take the average for the positive values, subtract the average for negative from the average for positive. In this case, it turns out to be 0. So this interaction term has no effect on the biomass. Is this clear?
Sir, 15 and 9 both are minus, but in least concentration you have taken 15 plus 13 plus 8.
Yeah. Just a second. 6, 15, 9, 8. Yeah, there's a mistake here. No? Six plus 15 plus 9 plus 8 divided by 4. This one will be 8 plus 10 plus 13 plus 7 divided by 4. 17, 23. So again, the answer will be 0 here.
Good evening. Sorry, I could log in a bit late. I think you have two more problems to complete. In which case, the six problems, if we could just revise, it would be helpful.
After these two, I'll go over all of them again. Is that okay?
Sure. Yeah.
Yeah. Yeah. So now it's correct, right? 6, 15, 9, and 8. Yeah, the
Yes,
answer
sir.
does not change. Yeah. Thanks for noticing that. Yeah. Yeah, again, so based on the data provided, what is the effect of dissolved oxygen and pH on biomass? Again, we'll do this multiplication, make a new column. Then we'll add those values. For minus it's 6, 10, 13, 8. For plus it's 8, 15, 9, and 7. Then we subtract the average for negative from the average for positive. which is 0.5. For the final question, we are asked what is the effect of temperature, pH, and dissolved oxygen interaction on biomass. So we'll multiply all three of these terms. So here -1 into -1 into -1 will be -1. -1 -1 plus 1 will be +1. -1 plus 1 -1 will be +1. And so on. +1 +1 +1 will be +1. So here we'll separate the negatives and the positives. For the least concentration, the negative values are 8, 15, 13, and 8. And the positive values are 6, 10, 13, and 6, 10, 9, and 7.
6 is 1 negative. -1 into +1 will be -1. And then again -1 into +1 will once again be -1.
Which one? Which row?
Oh, sorry. There are two -1. Sorry, I missed that.
Yeah.
Fourth
So
column.
we are multiplying all three of them.
pH and DO. Okay. Yeah. Then it's okay.
Yeah. So here, doing the similar thing, we find the answer here will be -3. Is this clear?
Just a minute. The fourth row.
Fourth row.
Will be -1
Yeah.
into +1 minus,
Mhm.
and then again -1
+1.
into +1 will be -1, and then -1
Yeah.
into -1 will be plus, isn't it? So you have 15 as a biomass.
It's -1 into +1 into +1, right?
Fourth row, I mean. That one.
This one. So -1 into +1 will be -1. -1 into +1 will be -1.
Ma'am, by mistake, I think you are again calculating the fourth column as well in the same multiplication pattern.
Yeah,
Oh,
so we are looking at
sorry,
all
sorry.
three of them,
Okay.
not
I
this one.
think there's some, sorry. I think the line I missed. Sorry.
Yeah.
Sir,
Yeah.
if the in a technical language, what could be we say if the answer comes in minus? What will be the technical matlab, language we could show or write as a result? What is the result of this particular calculation in a
Yeah.
technical manner?
So as someone mentioned, so basically it has a negative relationship. So if this factor temperature into pH into dissolved oxygen increases, the biomass should decrease. And if it's a positive answer, then as this increases, biomass should also increase.
That is one of the factors could have an inhibitory property, inhibitory effect.
Not one of those factors, the interaction between all three of them.
Okay, interaction. Okay.
Yeah. So for individual factors, we calculated this. So from this, we can say dissolved oxygen has a positive effect on biomass, and like pH has a positive effect, and temperature has a negative effect.
If the effect is negative, suppose the temperature effect is negative, so what we say ki it has an inverse effect, means by the increase in the temperature the biomass decreases, or the
Yeah.
vice versa, or the same ki by the increase in the temperature the biomass will be also going to be increased.
So if it's a negative relationship, then as temperature increases, the biomass should decrease.
Inverse effect.
Inverse relationship. Yeah, here you can see, So from these three, we note that temperature has an inverse relationship, pH has a positive relationship, and dissolved oxygen has a positive relationship. The interaction of temperature and pH has a inverse relationship, but the interaction of temperature and dissolved oxygen has no relationship. Sorry. So even if the interaction has
So
no
from
relationship or sorry.
so from these calculations, which factor is critical for biomass production?
Yeah, so we can just say about the relationships between all these factors and the biomass. we cannot say how much it increases and how much it decreases from this thing. So this number might give you a sense of like how much it's affecting. For example, 4.5 means this factor will affect more compared to 1.5. But like how much more and all, I don't think these numbers are directly comparable.
So, sir, finally, we could say if the answer is comes in a positive uh, pattern, so that says ki factor the factor of that particular equation will give a positive aspect. Like if the particular factor is going to be down, the biomass production or something whatever it produce is going to be down, and if it is
Yes.
going in a upward motion, then the answer or the significance will also go in a upward motion. And in the case of negative answer, if the answer comes in a negative way, so it will comes like an inverse. If the factor is going upward, the answer or the production or the significance will go downwards. This is the case, sir.
Yes.
Okay, thank you so much, sir.
Yeah. And also these values give you a sense of how much these factors affect biomass. For example, dissolved oxygen affects less compared to temperature and pH, like the interaction between temperature and pH, because this value is higher compared to this value. But I don't think you can directly say that this factor affects it 3 times more or something like that. Yeah.
Why we calculate in the least constraint first and the maximum constraint second?
Sorry.
Why we consider the least constraint first, maximum constraint second? Suppose maximum constraint first, least second. Second means some negative is changed, negative to positive, positive to negative.
No, because least con if you write this, I didn't get the question exactly. So what you're saying is we'll calculate this first and this second. Oh,
Yeah, yeah.
sorry, you're saying subtract it the other way around.
Yes.
Then you have to modify your statements accordingly. So if you are subtracting least from maximum, then you know that as temperature increases, like, so for example, you are subtracting least from maximum. So this means that you are assuming that temperature increases. And if you get a positive value here, then biomass also increases with temperature. But if you get a negative value here, biomass decreases as temperature increases. If you subtract the other way around, so maximum minus least,
Which
then
answer
you are
is correct,
assuming
sir?
temperature is decreasing. And if you have a positive thing here, then it's like inversely related. And if you have a negative thing here, it's similarly related. So you can do both of these, but you need to be careful about what statement you're making after that.
Thank you.
Yeah.
Sir, sir,
Yeah.
how would we know ki we should subtract from maximum to least or from least to maximum? How could we judge that statement? मतलब how could we could say कि हमें क्या करना है?
In most of the cases, you will have to do the first thing, but it does not matter if you do this or this. You need to be careful about what result you are getting here and how you are making the statement about it. For example, if I did least minus maximum and I got a positive thing on the right hand side, then I'll say that as temperature or whatever factor increases, biomass increases. And if I got a negative thing here, I'll say as temperature increases, biomass decreases. But if I did a maximum minus least, so I'm assuming that temperature is decreasing. And if I get a positive response here, then I'll say that these two are inversely related. And if I get a negative response here, then I'll say both of them are related, like going up or down in the same direction. You can do either of these. You need to be careful of the statement you make afterwards.
Arpit bhai, with respect to assignment, I think numerical value is also only required to put. So whatever you explain in all the uh, uh, solutions, we followed it. Am I right?
In the assignment, what values you need to put?
Only numerical value, I think Excel is that's questionnaire is allowed. So we need not to write anything text. That's a reduced 4.5 like this. Only minus 4.5 in just example, similar question is asked, then only we need to write minus 4.5.
No,
Yeah, yeah.
Jagdish sir, that is okay. But it in a case if that concept came in the final exam, what would we do at that time for the point of future prospects we are asking, Arpit sir?
This is, I think, Shivani, very clear that minus and positive sign. Minus sign, if we calculated from the maximum to minimum, then definitely increase. That means a positive effect, and negative in the sign indicate the negative impact. If we are not using same similar fashion, then everything will be reverse.
Yeah. So for the purpose of the assignment, do this one. Least minus maximum.
For the purpose of the assignment, please, what you said was maximum minus
Whatever we did here, least
yeah,
minus maximum, maximum minus least. Yeah,
So
sorry.
you
M
are
minus
saying
L.
least minus
M
L.
minus L.
Okay, we need to M minus L.
Uh, if if the 10th problem is over, if you could just indicate from
Yeah,
the
so we'll start again from the first one. Someone
yeah.
asked for the first one. Yeah. So the question here is 2 to the power 5 minus 1 design has how many experiments? So all we need to do is calculate it. 2 to the power 5 minus 1 is 2 to the power 4, which is 16. So it will have 16 experiments. Is that clear?
Yeah.
Okay. So the next question is 2 to the power 5 minus 1 design is a half factorial of dash experiments. So here, first we calculate similar to question one that in 2 to the power 5 minus 1, we have a total of 16 experiments. Then since we are asked is a half factorial, so we'll multiply 2 with 16 to get the number of experiments in the full factorial design, which is 32. So the answer here is 32.
Okay, the concept of half factorial. Okay.
Yeah. So half factorial means basically, so for this 2 to the power 5 minus 1, the full factorial will be 2 to the power 5, which will have 32 experiments. Since we are doing 16 experiments, we are just like halving the number of experiments that we are doing.
Yeah.
Like doing half of the number of experiments.
Yeah.
Yeah. So in this question, we need to say what is the number of experiments in the full factorial design.
Okay. Yeah. Yeah. That's clear.
Yeah. For the third question, we are asked 2 to the power 5 minus 1 design has a resolution of dash. So here we'll have 2 to the power 4 number of experiments. So we'll have 4 factors in the base design, which we can write as A, B, C, D. Then we'll write out all the interaction terms, first taking 2 at a time, 3 at a time, and then finally 4 at a time. Then to make this fractional, what we'll do is we'll replace the highest order term here with the new factor, which is E. So here our equation for this fractional design setup turns out to be E is equal to ABCD because we are replacing ABCD by E. And the generator equation here becomes I is equal to EABCD. Since the generator equation has 5 terms, the resolution here will be 5.
Since the okay, so what this means is that we are first of all listing out all the permutations and combinations. That is the individual components and their respective permutations and combinations. And then finally we get it as I is equal to E, A, B, C, D. So since there are 5 terms in it.
Yeah, this one comes from this equation.
I haven't come to this point in the lectures on the half factorial. That concept, if briefly it could be just highlighted. I'm just coming to that part today. Half factorial seem to translate it into, that is half factorial of something, let's say x, seem to be x into 2. So what is the it like that for all aspects? I mean, I wasn't very clear.
Sorry, half factorial turns out to be?
Half factorial of any design
Yeah.
based on the first problem. Sorry, the second problem it comes.
Yeah.
Half factorial was that number into 2 it worked out. So
So
how does it,
yeah, I'll
what
just
would be a 1/4 factorial or 1/6 or something like that?
explain it once. Okay. So 2 to the power 4 means
Yeah, 2
we
to the
have
power, yeah, 2 to the power of 4. What is a half factorial? 2 to the power of
no
4.
this is separate. I'm just giving you another example. Okay.
Okay.
So
Yeah.
let's say we have 4 factors
Ah,
and each factor has 2 levels.
okay.
So factors can be things like pH, temperature, desert, carbon concentration, nitrogen concentration, etc.
Mm.
Okay.
Yeah.
Levels means like low, high.
High.
Exactly. So if we need to like run experiment on this and see like something like biomass or something, how
Yeah.
it changes based on these 4 factors and these 2 levels.
Yeah.
So 2 to the power 4 will be our full factorial design. So in which we'll have total of 16 permutation combination of all these factors at all these levels.
Yes.
Okay. So that will be something like I stated here. So just a second. So for 4 factorial, we'll have 4 factors, A, B, C, D, and we'll have all these interaction terms.
Okay. Yeah.
Okay. Now, when we say that we are doing a half factorial design, so what we are basically doing is 2 to the power 4 minus 1. So here we are required to have 16 number of experiments. So we are reducing that to 8. So we are just doing half of them. So
It
in
works out
this,
to half of 16. Yeah.
yeah, 8 is half of 16. So here
Yeah.
what we are doing is we are building a full factorial using 3 factors. Let's say A, B, C. Then we have all these interaction terms A, B, B, C, A, C, and A, B, C. And finally, what we'll do is, so for each of these, we'll have like plus, minus, and all, no, low,
Yes.
high.
Yes.
So this will be low, 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 high, and so on.
Yeah.
Till we have plus, plus, plus. Then we can again calculate AB by multiplying these two. So it will be plus, this will be plus, and so on.
Yeah.
Then similarly for BC, it will be plus, minus. AC will be plus, minus. And ABC will be minus, plus, plus. So then to make this a fractional factorial for 4 factors, what we'll do is the highest order term, which is interaction term, which is ABC, we'll replace it by D.
Okay.
So now our experimental design becomes A, B, C,
D.
D. And then we have all these terms AB, BC, AC. So here D is equal to ABC because we replace that.
Okay.
Then similarly, AB will be similar to CD. Like these two will have similar tables like plus minus values. So here we have 8 rows in total of plus minus, right?
Yes. Yes.
Yeah. So for D, these row values will be similar to the values for ABC.
Okay.
For AB, the values that we have for plus minus here, it will be the same as for CD. For BC, it will be the same as AD. For
Okay.
AC, it will be the same as BD. And for C, it will be the same as A, B, D. For B, it will be the same as ACD. And for A, it will be the same as BCD. So what we are doing here is we are just reducing the number of experiments that we have, but we are introducing confounding factors.
Okay.
For example, if we had a full factorial design here, then we could have been easily able to distinguish between the effect of A and the effect of BCD. But here we cannot do that because both of them have the same values for these rows.
Yes, okay.
So we are losing on a bit of information to reduce the number of experiments. That is basically what we are doing. So for each of these fractional factorial designs, we have generator equations. Okay, for example, generator equations are like what we are replacing with what, basically. So here in this case, we are replacing D is equal to ABC and like CD is equal to AB. So all these things we can use as generator equations. So in generator equation, we just remove the plus sign. We just write DABC is equal to CDAB and so on. So the number of, for these generator equations, the smallest equation that we have, in this case, it will be 4. Like DABC will be the smallest one we'll have because all of these will have 4 terms. CDAB, ADBC, BCDA, all of these have 4 terms, right?
Yeah.
So the smallest equation that we have here, the number of terms in that gives us the resolution. In this case, it will be 4.
Okay, fine. Yeah.
That is what we are trying to do in the third question.
Okay, fine.
So in this second case, like if we take another example of 2 to the power 5 minus 2, this is a quarter factorial design. So we are like dividing the number of experiments by 4. So in the full factorial design, we would have done 32 experiments. Now we are doing 8 experiments. So again, since we are having 3 terms in the base design, we build this table. And then since we have 2 like quarter of it, we'll just replace these 2 terms by 2 new factors. So ABC will now become D and AC will now become E. So here we have the generator equations like D is equal to ABC and E is equal to AC. Of all the equations that we'll have for all these values, the shortest one will be E is equal to AC, which has 3 terms. Therefore, the resolution here is 3.
Okay, fine.
Yeah. For the next set of questions, we are given like this table of the effect of temperature, pH, and dissolved oxygen on biomass. We are asked what is the effect of temperature on biomass. So we are separating out all the minimum like -1 values for temperature, +1 values for temperature. We take the average separately and then subtract the biomass at least concentration from the biomass at maximum concentration.
Okay, temperature alone.
Yeah, this is for temperature alone. So we are just looking at this.
It is, I think earlier you were saying that it is always the maximum, that is the positives minus negative.
Yeah, +1 minus -1.
Okay,
Maximum does not mean the values that you get here.
Okay.
It's the value of +1 minus the values you get for -1.
The positive minus the negative.
Positive minus negative. Yeah.
Minus.
Then similarly for the rest of the questions, we again for the individual factors, pH, we take them separately, calculate the averages and subtract. For dissolved oxygen, we do the same. Now for the interaction terms, T into pH, first we need to multiply the temperature and pH columns to get the third column, T into pH. Then we look at the positive and negative values here, and again calculate the biomass at least and maximum concentration and subtract it. Similarly for temperature and dissolved oxygen and pH. And for the final question, we need to consider all 3 columns, the final interaction term, temperature into pH into dissolved oxygen. So we look at all 3 values to calculate the 4th column. Then we'll separate the -1 values from the +1 values. We'll take the average and subtract the -1 value from the +1 value. Is this clear?
Yeah, fine. Yeah.
Sir, can I have 2 requests with you?
Yeah.
Sir, first request is to upload this video earliest as possible because the explanation you did for the question number 2, I just skipped to listen some of the parts so that so because
Yeah.
of that I'm a little bit confused. While watching that video, I think I will be able to understand what you were saying in the question number 2. And second request is when in the week 6 assignment, there is a last question for the assignment they have given. I didn't get how they have given the answer actually.
Just a second. Week 6.
Yes, sir.
Yeah. So the question here was like you are given like the logarithmic cancer cell count for patients and before and after chemotherapy, right? And you are asked to use the Wilcoxon signed rank test.
Sir, it was done from my side. The last question for non-parametric for the question
Yeah.
number. Sir, how
Question number
come it?
7.
Yes, sir.
Yeah. So here what we are doing for question number 6 is like we are getting the difference. So we'll get positive and negative values, right? On
Yes,
that,
sir.
we'll use the Wilcoxon signed rank test that, as mentioned in question number 6. Then in
Yes, sir.
question number 7, we are asked, what other non-parametric test can we use? Since we have like positive and negative values, we'll use the sign test.
सर एक्चुअली आई गॉट कंफ्यूज कि क्योंकि इन्होंने जो वर्डिंग लिखी व्हाट अदर पैरामेट्रिक टेस्ट वी कैन वी यूज, मुझे लगा ओवरऑल मतलब अदर देन दिस असाइनमेंट हम और भी क्या कर सकते हैं
So
बिकॉज
they
ऑफ
meant
दैट.
like in question number 6.
हाँ, बट इट इज नॉट मेंशन्ड ओवर हियर कि ये क्वेश्चन नंबर 6 से रिलेटेड है. ये जो इन्होंने टैबुलर फॉर्मूला दिया है, इससे रिलेटेड ये कहीं पे भी मेंशन नहीं है सर.
You can
क्योंकि
write
जैसे
it in
ये,
the feedback.
हाँ सर प्लीज डू राइट फ्रॉम माय साइड बिकॉज ये जब कभी कोई 2 क्वेश्चंस या 3 क्वेश्चंस की टेबल किसी से अटैच्ड होती है, रिलायबल होती है आपस में, रिलेटिव रिलायबिलिटी होती है, तो वो शो होता है. यहाँ पे कहीं पे भी मेंशन नहीं था कि अदर देन अबाउट द क्वेश्चन नंबर 6, सो आई डिड द रॉन्ग वन.
There's a feedback form, no? You can fill into that, this exact thing
Sir,
that, yeah,
ओके सर.
they were mentioning about the previous question. Yeah.
sir, could you explain in question number 2 in week 6 assignment?
Week 6 assignment.
In question number 2, sir.
Just a second.
Shape and scale.
Mhm. So the question here is given shape and scale parameters for design AR 4 and 10,000. Design A, shape and scalar 4 and 10,000. Right. For design B are 5 and 11,000. So the shape thing is beta and this is eta. Right. We have a reliability function for Weibull distribution. which is given by e to the power e minus gamma by so here, since this is a two parameter distribution, the gamma is assumed to be 0. So this equation will turn out to be e to the power minus t by eta to the power beta. So can you guys see the screen? You guys can see the screen, right?
Yes, sir.
Yes.
Yes, sir, it's visible.
Yeah. So you just need to calculate the reliability for some random value, let's say 10,000 or something, for both A and B. Just input this instead of time. And then you need to compare which one of these is like greater. One by E. This will be 1 by E to the power. Just a second. Right. Yeah. This is something. Yeah.
Arpit, Excel has a variable distribution function, and where
Yeah,
we
yeah,
can
yeah.
get directly
No,
value.
no. I'm just checking something else. Okay. So here I don't think you need to use this function. You need to use the Weeble function. But you can't use Excel in your exam, no?
Yes, sir. That's why last time also I raised the same question. I think in this case, what I understand after I got the answer in the assignment, beta is nothing but the slope. Am I right? And the slope value is lower. That means the more reliable because there is a least
Yeah,
effect.
yeah, yeah.
So I think that's why this question was raised because otherwise very tough for the anybody. Because I had also calculated MTT. Just a minute, I see my full form MTTF and
Hmm.
also try to verify as well as I also draw the graph what you last time said.
Yeah.
But I
No,
didn't
sir.
find a easy way to get the answer. And last uh, one lecture, what I understand from the comparison of the slope, and another lecture they have said that how to calculate the beta and other functions in a equation. So I understand that beta is nothing but the slope, and slope calculations of on a different parameter. I think 0.5, 1, 3, and another more is given in that particular lecture.
Yeah. So as beta increases, the
Sir, I've
failure rate
used
will increase over
Excel, sir.
time.
I've used Excel.
Yeah, yeah.
I've used this
So,
function,
uh,
Bible 10,000, comma 4, comma 10,000,
uh,
alpha, beta,
okay.
comma true. I am getting 0.63 for A, 0.46 for B.
Yeah.
In Excel, I've used.
You can do that for now. But in exam, I think you need to use this equation and calculate.
In exam, we don't have Excel, this thing.
No, exam, you don't have Excel.
But
It's clearly mentioned in the announcement that in exam we will get a digital calculator. In the exam period, nothing else will be taken from our side. We are not supposed to take calculator, mobile phone, nothing else, and they are not going to give you Excel or anything else. They are only going to give you provide a digital computer while calculate for the calculations.
Yeah.
sir, another in the lecture they have told that Bible of alpha beta.
Hmm.
Once I get that, it is a survival probability or reliability. That's what I've recorded in the lecture notes.
They talked about the failure
Which
rate, right?
particular problem?
Survival probability, then 1 minus survival probability, they are given as reliability.
Yeah. Yes. What I understand from the lecture. Yeah.
And in that case, B will be the answer because B has more reliability compared to A. I mean, if I can present it, I can show the Weibull distribution Excel.
Yeah, sure. Go ahead.
Shall I present it, sir?
Just a second. Yeah, you can go ahead, present it.
Just I'm is it visible?
No.
Not yet. Yeah, continue. Ask.
Yeah. Now? Is it visible?
Yeah.
Yeah,
See,
it's
for
visible.
1000, this is Weibull of 10,000. Alpha is that is the slope, B, 4. Shape is
Beta,
10,000.
beta.
And true, I'm getting 0.60. That is survival probability. That's what I heard from the lecture. And for the same values for Weibull, for slope is 5. Shape is 11,000. I'm getting 4.6. Is this reliability or survival probability? I'm confused, sir.
In the solutions, our answer is different.
That's what I'm confused whether this is the answer. We have to take 1 minus survival probability.
This is the answer, sir. So
Or
they included
or
1000
this is the
also
answer.
in Webull.
Just a
Alpha they
second.
consider 1,000, then
Huh?
5,
I think
then
W sir
eta.
has said once ki more the reliability, more the probability, more the acceptance of the product.
Now, what is reliability formula? It's 1 minus survival probability, or this is the
Reliability is
reliability.
1 minus failure rate. Right.
That is survival probability. I'm getting
Just a
minus
second.
0.7. This is minus 0.9. Which is better?
Minus 0.7 is better.
Then it can, that case, A
Yeah.
is the answer. Huh?
Yeah.
I have plot the graph. If you wish, I can share my Excel also. And no doubt I
Graph, what can you
interpreted
plot,
that.
sir, for this? For minus 0.7?
You
The
sure you
same is
can go
mentioned in the
and
solution.
Solution, they have mentioned A, no? Answer.
Yeah, so
yeah, A they have mentioned. I think you are taking
in
10,000 in
solution, the
solution, they
value
have taken
is
1,000. That's why the value is different here.
So 10,000 only here.
In solution, they have taken 1,000 as alpha, no?
No, no, alpha is
not
10,000.
1,000, sir. 1,000.
Slope is 4. Slope is, beta is 4. Alpha is 10,000.
Alpha is 1,000.
1,000 in the question?
No, 10,000 and 11,000.
That is
10,000
eta,
and...
no? That is the
Eta.
scale.
And,
that's what
and
eta
beta is
taken
4
no.
and 5.
Scale they have taken
This
10,000.
is alpha is slope. Beta is
The first value that you are taking, the number of cycles you are taking 10,000, they have taken 1,000.
Yes, sir, they have taken, I think.
but
That's why
even
your
if I
values
reduce
are different.
one,
Yeah,
they have
I
taken.
have also utilized different value and
No,
compared with the
cycles is just a time, no? I mean,
Yeah. So here
that doesn't-
you should look at survival probability only, no? Like you can get it from both of them, but I think it's better to look at survival probability.
survival 1,000 only I have to take here.
1,000 if you take, you will get the same answer as they mentioned, I think.
Yeah.
But you can take
taking the
10,000 or whatever value. Just don't take a very large value because both of them will become one.
Yeah, that's what.
Hmm.
Now A is better. Huh? A is having more reliability. That's what.
A is better, yeah.
Because minus 0.7.
Yeah.
Okay. Okay, I'll stop sharing.
Yeah. Someone else was asking something.
And another thing, sir, probability of 0.05 in the second, 6th week, fifth question, 6th week, 5th question. I didn't get that. How is a student of 10B are better than 10A? Week 6, question 5. I'm having a doubt about that. That's why.
Just a second. Rank sum of 10B is 134. Rank sum of 10A is 76. You need to look at the table, no?
Table value, huh? Okay.
Yeah, you need to look at the table value. I think the table value is 77 or 78. So since it's lower than the table value, it's significant.
Table value was 87, sir. So for the
It is.
87 table
So
critical
table value
table
is,
value was 87, sir, at that time in that question.
yeah. So table for these non-parametric tests, the value that you calculate should be lower than the table value. Then only it's significant.
Just had a query. Now, videos such as this session, what is the link for where they are uploaded? I looked for it, I couldn't find it.
Where I think in the problem solving session tab you have on the left, no?
Problem solving session.
Ma'am, when we open our profile in that Swayam web app, there is a heading mentioned in the last one, problem solving session. When we click on that, then again we get a link to click on that. When we open that, there is an Excel sheet opened, and
Yeah.
there is a second column that is it is YouTube link. You can clearly visit from there as well.
Sorry?
Under the link called My Profile. I didn't get you.
I didn't get you, yeah.
Ma'am, when we open our personal profile in Swayam from the
Okay.
course, week 1, week 2, week 3, there are
Yeah.
lots more columns. There is a
Yes.
last column mentioned. I just
Problem
opened.
solving session. Yes.
Yeah.
Yeah.
When we click on that, there is again problem solving session. When we again click on that, then we will get a problem solving session with a click here to view the problem solving sessions lecture.
Okay. Oh, yeah.
By,
Thank you. I
by
got it.
Yes, ma'am.
Yeah.
By clicking from there, we will get a open to Excel sheet. From there, there is a column B.
Because actually there was a bit of a in that week 6 first question, the explanation given by Dr. Arpit and in the other,
Yeah,
like,
I told you, no, follow whatever Amit told you.
okay.
Yeah.
Yeah, because that was a
I
bit.
still feel like this is not the way they calculated, but
You
yeah.
had 1 by mu, sorry. That is lambda is equal to 1 by mu was your interpretation. Whereas there they
Yeah.
have taken it as the
They have
directly.
taken lambda is equal to mu only.
In fact, I followed what the methodology that you had explained, but I was surprised to find the answer was different. And then I found that in the problem solving session, this is how they had worked it out.
Yeah, in the end I mentioned, no, like follow whatever Amit told you, the other team.
Okay.
Sir, I have doubt in week 7,
Yeah.
second questions.
Week 7, second question.
Yeah, sir. In the problem which you explained based on 1 by 2 factorial differential. Instead of 1 by 2, if we have 1 by 4 or 1 by 6, how to solve, sir?
Just a second. Number 2. Yeah, so since this is a half factorial design, they asked you for half factorial. If there is 1 by 4, then you multiply it by 4.
Oh,
So the number
okay,
of multiply it 16 by 4. If it asks you, this is a quarter factorial of dash number of experiments.
Okay, sir. Okay, thank you, sir.
They'll most likely try to tie these up together. So if there's a 1 here, it should be half factorial. If there's a 2 here, it should be quarter factorial, 1 by 4 and so on. But in case it's not like that, all you need to do is like multiply whatever the denominator here is with the total number of experiments in the fractional factorial. So for example, if the question was 1 by 4 factorial, then we would have multiplied 16 into 4 to get this.
Okay, sir. Thank you, sir.
Sir, question number 3, sir, answer is 4, na? 2 raised to 5 minus 1 design has 4 resolution.
5.
5. Okay.
This one.
So
So
please try to upload this session's video for on the problem
yeah, I'll
selection,
upload it today.
because I'm very much confused in the third question, and by recalling all the explanation you have done, I think so I will able to understand that actually.
Yeah, I'll
Sir,
upload
and
it
2
today.
raised to 5 minus 2 answer is 3.
Yeah, for that question, the answer is 3.
Okay. Okay, sir.
Does anyone else has any more questions? Just a second. Yeah, you can type the question. Formula as in like how to take the. Okay. Yeah, you can give the values. Here is. N is equal to 15. N is equal to 10. X is okay. Yeah, so the formula here is this for hypergeometric distribution. So probability of X is given by C of capital S by small x into C of capital N minus capital S by small n minus small x divided by C of capital N by small n. We are given these values. Capital N is 50, small n is 10, capital S is 5, and X is 4. Okay, so to calculate, we just put all these values. C of 5 by 4 into C of capital N minus S is 45, N minus X is 6, divided by C of 50, 10. Yeah, so C of K given R is given as K factorial by R factorial into K minus R factorial. So you need to substitute these in all three terms. Okay, so here it will be 5 factorial divided by 4 factorial into 5 minus 4, which is 1 factorial, into 45 factorial divided by 6 factorial into 45 minus 6, which is 39 factorial, whole divided by 50 factorial divided by 10 factorial into 40 factorial. Then all you need to do is just calculate. So factorial x factorial is given by x into x minus 1 into x minus 2 dot 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 till 1. For example, 3 factorial is 3 into 2 into 1, which is 6. So you can substitute the factorial values here and get the answer.
So for 45 factorial, we need to calculate till the 45th steps comes up.
So most of these terms will cancel out. For example, if you look at this part of the equation, so it's like 45 factorial divided by 6 factorial into 39 factorial. So 45 factorial you can write as 45 into 44 into 43 into 41, 40 into 39 factorial divided by 6 factorial into 39 factorial. So this part will cancel out. Then this will be 6 into 5 into 4 into 3 into 2. You can just divide these. I think in the online calculator, you should have something for factorial.
Because there it's coming as 1.66 to 10 to the power of.
Sorry.
It's coming as 1.66 into 10 to the power of 53. The answer I'm getting for that. 45 factorial divided by 6 factorial.
Yeah, you can do it in the calculator. Is that what you're saying? So the answers will come very high. The values that you will get will be very large. For example, if you have seen in the video, yeah, the values will be very large.
Yeah, 10 to the power of 53, like that it's coming.
Yeah. I don't think there's a factorial thing here in the calculator. Ah, there is, no?
The third column, third.
Yeah. Just a second.
In factorial.
Yeah, you can see, no? For example, you put 45 and you press this button. It gives you the value for 45 factorial. So it's quite large. So instead of that, I would suggest like cancel out all the terms, and after that, whatever you are left with, just multiply those in the calculator.
Okay, sir.
In this way, you are most likely to miss a lot of terms. Or you can do something like this was 55 factorial divided by
6 factorial.
6 factorial
Equal
into 39 factorial. Yeah. So you can do something like this to get direct values instead of like multiplying or canceling out the terms. You guys just need to practice with this calculator a little bit. You can do a lot of things in this.
Arpit, you pressed T A and H. Am I right?
No. The button below that, n factorial. There is pi e and there's n factorial.
Yeah, I got it. Okay.
Online, the position of that cursor is differing. Where the cursor shows on the scientific calculator, not able to make out very clearly online. Looks like it's on the row above, like that.
Yeah, I press this button, n factorial. The one below tan h.
Yeah, correct.
There is a button called n factorial. Can't we use directly to that?
Yeah, that is the one we are using.
Yeah.
Third row,
Yeah, third row, the third item. And
Third
third
row, third
column.
column. Yeah.
by using that factorial third row, third column, the button provided from there, we can calculate the factorial from there as well, na, sir?
Yeah. That is what we are doing.
But
So
here there are so many brackets open over there, na, in your statement. So because of that, I got confused. So we need to put those brackets as well.
yeah. You need to put those brackets as well.
Okay.
I think the first bracket, this one you can leave, the one around factorial 45. But below, I think you need to put a bracket for that multiplication thing.
Okay, sir. Okay, sir.
Yeah, this is the factorial tab. I don't know what exactly you guys are seeing. I'm putting it on the factorial thing. It's the third row, third column, right beside
Now I
E.
understand.
Yeah.
Sir, please do it again so that we can understand how you have done the calculation step by step.
Yeah, so what we are trying to do here is factorial 45. So first we'll press 45, then we'll press the factorial key. Then we need to divide it by factorial 6 into factorial 39. So here I need to put a bracket so that it will multiply first and then divide. Right. So I'll again type 6. I'll press factorial. So this is factorial 6. I'll press multiplication 39. Then again factorial. Then I'll close the bracket and I'll press equals. Is that clear?
Okay, sir. I think we need a lots of practice for this before we go to this exam center. We need at least 1 hour practice to understand the exact of all the
Yeah.
values and how to calculate that.
I don't
Actually,
think I can
for
enlarge the
solving the
calculator.
assignment problems, we can just use this scientific calculator, then we'll get used to it.
Hmm?
For our assignment problems, if we use this scientific calculator, I find we are getting used to it.
Yeah, that's a good idea.
Yes, ma'am. While doing the assignments, we should use this.
Because rather than use our regular calculator, this helps. How did you enlarge it? I missed that.
I just zoomed in. I think Archana asked to enlarge it. It says, no, it's the button below TANH. There's a button that says n factorial. I have typed it out.
In third column,
Third row.
pi e and n factorial. So n factorial
Pi
is third one.
n factorial. This button.
Actually, RPG, your cursor is moving differently when you are speaking the things. That's why people are confusing actually.
Yes, that's why we all getting confused because you
Ah,
are doing n factorial and while doing factorial from your
Yeah,
side, the cursor comes at tan
yeah, it's
or
coming in
cos
Okay.
the
h.
row above. That's what's happening.
Okay, now
Sir,
is it
please
on n
upload this video as
factorial?
soon as
no.
possible.
That on 10H. Right now your cursor on 10H minus.
Yes, tan h inverse.
Now?
And yeah. Slightly move to the right side. Slide.
Yeah, now
Right?
move to the right.
Yeah.
Yeah,
Now
now it's there.
perfectly fine. This is
Now
n
it's there.
Okay.
factorial.
Now it's on NH. Yes, sir.
Okay, so this button you need to click.
Okay, sir. That's why I got little confused. Sir is saying the cursor is moving there and sir is doing n factorial.
Yeah.
Sir,
Okay.
please try to upload this video because for question number 3,
Yeah,
I need to recall that
Yeah, I'll upload it
explanation you
right
have
now.
given for men and ma'am.
Yeah, I'll
yeah.
upload it
Actually,
after class.
resolution. I think we need to study a little more in depth on that because
Yeah,
this
you can
assignment.
watch the videos. It's kind of easily explained in that.
Yeah, in fact,
I
I've
don't think
just
it's that complex.
I'm in the middle of week 7. So I couldn't finish all the videos before coming to your class today.
Yeah, that's okay. So we'll stop here today.
Yeah,
I'll
Yeah,
thank
sure,
upload
you,
the
sir.
Arpit
videos
bhai.
after
Thank you,
this.
sir.
Yeah,
Thank you
okay.
so much.
Thank you.
Thank you so much, sir.
Yeah.
Bye, sir.
Bye.